Okay, the other type of naming we're going to look at are two nonmetals. So we've looked at a metal and a nonmetal. We've looked at a metal and some polyatomic ions that also have negative charges, so they're ionic. These actually are different things. They're called covalents, which we'll explore later. But how we name them when we have two nonmetals is that we're only going to use prefixes. Okay, now the prefix for one is not used with the first nonmetal, so we never, for instance, see this is carbon monoxide, but we don't say monocarbon monoxide, we just say carbon monoxide. So if there's just one of the first, we don't use that mono term. If there's just one of the second, then we do use the mono term. The prefixes, one will be mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. Okay, so these are pretty straightforward. Again, these are subscripts here. This should be a CO2. There are no charges here. There's no charges that we're going to look at. And that's another whole way of bonding that we have not yet looked at, when we will. But just realize that don't worry about charges when you have two nonmetals. Just name them. Dinitrogen monoxide, dihydrogen monoxide. That is the term for water. Some of these are so common that we don't use the classical name. Nitrogen trihydride is just ammonia. No one would ever refer to it as nitrogen trihydride. Okay, so there's a worksheet on that one that you should definitely do. There's other naming systems that are kind of an older naming system, and it assigns the transition metal a lower and a higher charge. The lower charge is called Us, and the higher charge is called Ik. So you may see like ferric chloride or cuprous oxide. We're not going to be studying this naming system. If you happen to come across one in your book, I think I've mentioned all of them, but if you happen to just this Ik or this Us, just let me know or skip it, and we'll come back to it. Now, the systematic way to name acids is this. If there's no oxygen in the acid, now I should hold off and tell you very simplistically what an acid is. An acid is something where you have a hydrogen and then something else. Okay, hydrogen, then something else, hydrogen, then something else. So that's a very simplistic way to look at it, but we'll delve into acids later too. If there is no oxygen in the acid, you name it with hydro, then its root name, so chlorine becomes chloro, and then ic, acid. So this is called hydrochloric acid. This is called hydrobromic acid. Now, before this, you would have named this hydrogen chloride and hydrogen bromide, and that's actually not incorrect. It's just that if you're going to name it as an acid, this would be the acid name. If there is an oxygen, you look at what the polyatomic is. So if you look at your polyatomic list, and you absolutely should, this is the sulfite ion. And if it's a sulfite, what we're going to name is we're going to name the acid with the root name of the polyatomic and end it with us. So none of this hydro business. So we're going to start with sulf instead of ite. We're going to go sulfus acid, or actually sulfurous acid. Right here, this is the phosphite ion, not to be confused with the phosphate. This is the phosphite. So phosphorus acid. So sulfurous acid, phosphorus acid. So if you've got a polyatomic with a sulfate, an 8 ending, phosphate, these are going to be much more common. This is going to be sulfuric acid, probably the most used chemical in the United States, not just the most used acid, but the most common chemical. And this is phosphoric acid, sometimes found in sodas, pop. Okay, honestly, outside of that systematic way of naming things, these are the acids you should know. So grab some more flashcards, write them down. H2SO4 is sulfuric acid, HCl hydrochloric, HNO3 nitric, HC2H3O2 is acetic, and H3PO4 is phosphoric. Realistically, those are the three I'm going to be asking for you on the test, but these are pretty common as well. Okay, that's it.